There are 5-point charges, each of value plus q, are placed on 5 vertices of a regular hexagon of side L. So there is a regular hexagon of side L and 5-point charges. That means one vertex is there which is empty. So 5-point charges, each of value plus q, are placed on the 5 vertices of regular hexagon of side L. The magnitude of the force on a point charge of value minus q coulomb placed at the center of the hexagon. So we have to find the force on a charge which is placed at the center of the hexagon. So here the hexagon is having the size L. That means this is L, this is L, as we know that equilateral triangles are formed. Center, this is a regular hexagon. And 5-point charges are placed at the corners. So the 5 corners are occupied by plus q charges and the 6th one is empty. And there is another charge minus q which is placed at the center of the hexagon. So here it is a minus q charge and rest charges are plus q. So here you can see it clearly that if there was a charge at this corner also, then what should have been the net force on this charge? 0, because the oppositely placed charges will cancel their force on this particular charge. If there was one more charge here, then net force would have been 0. So what is the situation? This is the force applied by this charge on the center. So the opposite force must be applied by this charge on this. So these two forces are cancelled from each other. And similarly, you can see that this charge applies attractive force on this because this is negative. It's not repulsive force. So this force is applied by this charge and this force is applied by this charge. So these two are cancelled, and similarly this charge is attracting this one and this charge is also attracting this one with the same amount of the force. So these two are also cancelled. So remaining force is this, which is not being cancelled by the charge if it was there on this vertex of this hexagon. So net force on this particle will be the force purely due to this charge. So we have to find the force between these two charges only. It's quite a simple question. So force is 1 upon 4 pi epsilon naught into q1 q2. q1 q2 will become q square divided by square of the distance. Distance is L. As we know that from center, each corner is at a distance L, which is side of the hexagon also, as we know that. So this is the answer. So option D has to be the correct option to this question. In case this particular system was pentagon, even then we can use the similar argument. Okay, in case of pentagon, the 5 forces will be there. If all 5 corners of the pentagon are occupied with the charges, then they will apply 0 force on a charge placed at the center. So if we remove any of the charges from vertex of the pentagon, then the net force will be due to only the remaining one charge. So the same kind of argument can be used for the pentagon also.